Enamel and dentin adhesion is a very important subject in dentistry. We will be studying this subject for about 2 hours. Let's start by talking about the importance of enamel and dentin adhesion. Here we can see the adhesion is a state in which two surfaces are held together by interfacial forces, which either valence force or interlocking force, or both. Valence or interlocking force, which are very important forces that we should discuss in order to understand what is the adhesion force. Let's read it in another voice.
Adhesion is a state in which two surfaces are held together by interfacial forces which either valence forces or interlocking forces or both.
This was a reading to understand the adhesion force. Let's read it again in the text-to-speech.
Adhesion is a state in which two surfaces are held together by interfacial forces which either valence forces or interlocking forces or both.
So adhesion is a state in which two surfaces are held together by interlocking by interfacial forces, which either valence force or interlocking force. Valence or interlocking force. Let's see what valence force means. We will discuss what valence force means in the next slides, but the interlocking force, I don't know what is the meaning, or it is mostly being a mechanical force. A mechanical force. Next, in this slide, we have adhesive. Adhesive
is a material, viscous fluid, that joins the surfaces, substrates, together by solidifying and transferring loads from one substrate to the other.
So adhesive, let me try this again to read it loud.
Adhesive is a material, viscous fluid, that joins the surfaces, substrates, together by solidifying and transferring loads from one substrate to the other.
This is the adhesive definition. Is a material or a viscous fluid that joins the surface's substrates together by solidifying and transferring loads from one substrate to the other. Let's read the adhesion and adhesive together in order to understand what is the difference between adhesive and adhesion. Let's highlight this one first. And let's read the definition of both forces.
Adhesion is a state in which two surfaces are held together by interfacial forces, which either valence forces or interlocking forces or both. Adhesive is a material, viscous fluid, that joins the surfaces, substrates, together by solidifying and transferring loads from one substrate to the other.
So we understand that adhesion is a state in which two surfaces are held together by interfacial forces, either valence or interlocking, and an adhesion is a third material, viscous fluid, that joins the surfaces substrates together by solidifying and transferring loads from one substrate to the other. We can say that adhesion occurs within the same material, and adhesive occurs between two materials. Let's move next to the next paragraph. We have the
adhesion strength or adhesive
adhesion
strength or bond strength is a measure of load-bearing capacity of the adhesive joint.
Or adhesive strength, adhesion strength, or bond strength, a measure of load bearing capacity of the adhesive joints.
Adhesion strength or adhesive strength or bond strength is a measure of load-bearing capacity of the adhesive joint.
Is a measure of load bearing capacity of the adhesive joints. Also an important definition. Let's move now to the next paragraph, or to the next slide. Here we have the benefits or the advantages of the adhesion force. As we talked earlier, that the adhesion force is a strength between the same material, or two material, from valence and interlocking force. Valence and interlocking force.
Less cavity preparation, more conservative, no retention form, in addition to improved filling materials, improved physical properties.
So, in less cavity, or the less cavity preparation, that is more conservative, no retention form, in addition to improved filling material, improved physical properties. This is the meaning of the advantage, or this is one advantage of adhesion. It needs less cavity preparation, more conservative, no retention, form, improved filling material, improved filling or physical property. Again, more conservative. The same meaning is less cavity preparation, and the other same meaning is no retention form. It needs no retention form. In addition to improved filling materials, that's an improvement in physical properties. Next advantage of adhesion is this one.
Strengthening the unsupported enamel.
Strengthening the unsupported enamel. That means it does support the unsupported enamel. Let's read this again.
Strengthening the unsupported enamel.
Strengthening the unsupported enamel. Very important feature
Strengthening
of
the unsupported
adhesion.
enamel.
As the unsupported enamel is a problem in all kind of tooth structures. The unsupported enamel or a fried enamel, it is a problem in all kind of teeth structure that must be removed or strengthened. On this occasion, we have the adhesion to support the unsupported enamel. And of course, the first one is the conservative nature of adhesion. Third advantage, we can say that occluding dentinal tubules decrease phosphorylation sensation or postoperative sensation.
Occluding dentinal tubules decrease postoperative sensation.
Occluding dentinal tubules decreases the postoperative sensation. Of course, another advantage or another benefit of using adhesion is decreasing the postoperative sensation. Decreasing the postoperative sensation. This one is talking about the adhesion bonding. The adhesion bonding. We were talking about adhesion, but this time it's talking about bonding, as it is same as adhesion. It is same as adhesion is bonding. We read before the advantages of adhesion, and now we know that adhesion equals bonding. There are 4 types in operative dentistry. We can read them right away, just to understand or to take a general idea of the bonding 4 types in operative dentistry.
4 types in operative dentistry. 1. Mechanical, penetration of resin within tooth structure and tags formation. 2. Adsorption, chemical bonding, inorganic equals hydroxyapatite, organic equals collagen mainly. Type I. 3. Diffusion, precipitation of substances on tooth surface to which resin monomer can bond mechanically or chemically. 4. Combination, all above.
So these are the 4 types of adhesion or bonding in operative dentistry. The first one being the mechanical, second is adsorption, then we have the diffusion and the combination. Let's start with the mechanical penetration of resin.
Mechanical, penetration of resin within tooth structure and tags formation.
It's just a mechanical adhesion force, meaning that it do penetrate, or it is the penetration of resin with or within tooth structure and tags formation. This is a very important definition here. The mechanical penetration. The mechanical penetration. First one, mechanical penetration of resin within tooth structure tags formation. Next, we have the adsorption. And the adsorption is chemical bonding it is a chemical bonding that is inorganic hydroxyapatite, organic collagen, mainly type 1. This is the adsorption force and the mechanical force. Then we will study the diffusion force of bonding. Diffusion force is precipitation of substances on tooth surface in which resin monomer can bond mechanically or chemically with the bonding material. Again, precipitation of substances on tooth surface to which resin monomer can bond mechanically or chemically. Then we have the combination all of the above mentioned types. All are called combination. The diffusion, the absorption, And the first type, the first is the mechanical penetration, adsorption with resin bonding, diffusion with precipitation of substance, and all are important in operative dentistry. Let's move to the next slide. After we studied adhesion in this 32 slide lecture. We have here the good adhesion achieved by close contact between the resin bond and enamel dentin. Resin bond, this one, to make a good adhesion, we need a good contact between the bond resin and the enamel dentin. Here and here. And of course, a good contact would be optimal. Next, good adhesion could be or can be achieved with using surface tension of bond, which must be less than surface free energy. Next slide. We have additional features. These are the additional features. As we can see here, coercive failure and cohesive failure, also adhesive failure. Coercive failure, when a substrate or a friable enamel infected dentin could make a cohesive failure. This is about adhesion, not adhesive. Adhesion could make cohesive failure. Substrate, friable enamel, infected dentin, infected dentin is a cohesive failure. Next is the cohesive failure also. Adhesive material could cause this adhesive failure. The adhesive failure might happen with joints, which is different from the two cohesive failure. Very different from the cohesive failure is an adhesive failure that could happen between the two materials within the joint. This is a joint, and we can see that the adhesive failure might occur between these two joints. These joints, and the cohesive failure will happen right in between these two bones or structures at the enamel. Polymerization shrinkage occurs due to all methacrylate-based resin shrink major problems, so the adhesive must provide strong bond to resist stress of resin shrinkage. Polymerization shrinkage occurs due to all methacrylate-based resin shrinkage. The methacrylate major problem, so the adhesive must provide strong bond. Adhesive must provide strong bond to resist stress of resin shrinkage. To resist the resin shrinkage stress. Moving to the next, enamel adhesion. This word is bunicorn or bunicore. %, phosphoric acid for 1 millimeter. Let's read this page to understand what the enamel or the enamel adhesion means.
Buonocore, 85% phosphoric acid for 1 minute, 60 seconds. This process, named acid etching transfers smooth enamel surface to an irregular surface and increase its surface free energy. Aids by capillary action, and after applying adhesive material they polymerized and formed a micro tags, retention.
So this is all about enamel adhesion. Very important subject. The bony core, 85% phosphoric acid for 1 minute. Exactly 60 seconds. The buno core, %, phosphoric acid. The material Bunicor 85 phosphoric acid applied for 1 minute in enamel adhesion. Of course, before we talked about adhesion failure, but we didn't talk about the enamel adhesion. Just generally about the adhesion and good adhesion advantages, failure, properties, etc. But now we can see the Bunicor 85% phosphoric acid, which must be applied for 1 minute. The process is named acid etching. The process is called acid etching. What is acid etching? Acid etching is the application of Bunicor 85% phosphoric acid for 1 minute. Etching is the application of 85% phosphoric acid for 1 minute on the enamel, or the application of Bunicor for 1 minute on the enamel. Acid etching transfer smooth enamel surface to an irregular surface and increase its surface free energy aids by capillary action. And after applying adhesive material, they are polymerized and formed, or they are polymerized and form the macro leakage, which of course make retention. This retention is what we need for the adhesion force to work correctly. Let's move to the next slide. We will be talking about enamel etching micromorphologically. Enamel etching micromorphological. We have the type 1 dissolution of prism cores. Enamel etching micromorphologic. As we can see in these pictures, we have the dissolution of prism cores. Dissolution of prism cores as the prism cores appears to be dissoluted with the phosphoric acid 85%. Type 2 dissolution of periphery. This picture showing us the type 2, which looks more regular dissolution. This one looks more regular dissolution. The type 3 dissolution looks more complicated and bigger than the first one, or the first dissolution. The replica of enamel. In this slide we can see the replica of the enamel. Basically an enamel being etched by an etching material, bony core, 85% phosphoric acid. Acid etch concentration between 30 and 30%. 35 is phosphoric acid, and the time is from 15 to 30 seconds. And the most important concentration is 35%. Of course, the time is very crucial in this point to etch the enamel.
If they increase then normal precipitation of calcium and phosphate groups and act as a barrier and dissolution of collage fibers.
And this explains that the calcium and phosphate group act as a barrier of dissolution of collagen fibers. There is liquid and gel, and the force of adhesion in this case is from 20 to 50 MPa or millipascal. The dentin adhesion with a micro mechanical penetration of adhesion monomer into collagen network. The dentin adhesion, micromechanical and chemical. For the micromechanical being the penetration of adhesive monomer into collagen network. And the chemical for adhesives that do not need acid etch as GIC, polycarboxylate group, polycarboxylate group phosphate based monomer with hydroxyapatite, as we can see in this picture. Very clearly we can see the chemical and the micromechanical dentin adhesion. The chemical is an adhesion that do not.
For adhesives that do not need acid etch as GIC, polycarboxylate group, phosphate-based monomer with hydroxyapatite.
Mainly the GIC polycarboxylate group, phosphate-based monomer with hydroxyapatites. GIC, polycarboxylated group, phosphate or phosphate-based monomer with hydroxyapatites is the chemical type of adhesion. Challenge in dentin bonding. In this slide, high water, 25%, and organic contents. The first challenge in dentin bonding is the high water, 25%, and organic contents, 25%. These are the challenges in dentin bonding, for the water being 25 and the organic content being also 25. Network of tubules that contain odontoblasts is another challenge. And enter tubular sub-micron channels, intertubular submicron channels, flow of fluid from pulp to dentino-enamel junction through tubules, number of tubules that pulp, which could be more than 45,000 per millimeter square, and the number of tubules at dentino-enamel junction, which is less, about 25,000 per millimeter square. And of course, applying the dentin bonding at the enamel is less effective than applying it on the dentino-enamel junction, or at the pulp is less effective than applying it on the dentin-enamel junction. Therefore, applying the dentin bonding at the enamel is less, or at the pulp is less effective. And applying the dentin bonding at the dentino-enamel junction is more effective. Diameter of tubules at pulp is 2.37 micron, which is considered very big compared with the dentino-enamel junction diameter of tubules, which is only 0.6 micron. And therefore applying the dentin bonding at the pulp would be less effective. Let's highlight this one more time. In order to understand it better.
High water 25% and organic contents 25%, network of tubules that contain odontoblasts, intertubular submicron channels, flow of fluids from pulp to dage through tubules, no of tubules at pulp equals 45,000/mm2, no of tubules at dage equals 20,000/mm2, diameter of tubules at pulp equals 2.37 micron, but at dage equals 0.63 micro.
And Let's read it
High
again.
water 25% and organic contents 25% network of tubules that contain odontoblasts intertubular submicron channels flow of fluids from pulp to dage through tubules no of tubules at pulp equals 45,000/mm2, no of tubules at dage equals 20,000/mm2 diameter of tubules at pulp equals 2.37 micron, but at dage equals 0.63 micro.
The dentin is dynamic substrate, as this title is saying. The dentin is dynamic or is a dynamic substrate. Let's read this and then we will carefully
And for these reasons
analyze
adhesion
it.
affected by dentin thickness, depth, more deep cavity less retention except, one-step self-adhesion, show no difference among different depth cavities.
As the dentin is a dynamic substrate, for these reasons, the adhesion affected by dentin thickness, depth, and it must be, or it must has less and small depth in this case, and thickness. More depth cavity equals less retention except one-step self-adhesion. Which shows no difference among different depth cavities. Among different depth cavities. With only one-step self-adhesion, which is rare. The smear layer definition.
After preparation of tooth with residual organic, denature collagen, gelatinized due to friction heat, and inorganic, hydroxyapatite, components form a smear layer of debris that fills the orifices of dentin tubules forming a smear plug.
Of course, a very important definition that we should make a drawing in order to understand what does that mean. So after preparation, as we can see, of tooth with bore or a residual organic denture collagen, gelatinized due to friction heat, and inorganic hydroxyapatite components form a smear layer of debris that fills the orifices of dentin tubules, forming a smear plug. And the smear plug can be seen in this picture. Here we can see the smear plug. Again, after preparation of tooth, with bore, residual organic denture collagen, gelatinized or gelatinized due to friction and heat. We can draw this gelatinized area here on the tooth. This is the gelatinized dentin. And it could cause a plug that prevents the bonding material to be inserted. Gelatinized dentin. Due to the preparation of tooth with a bore, the residual organic denture, collagen gelatinized. Due to friction and heat. There is many heat here and friction causing an inorganic hydroxyapatite components here, the hydroxyapatite component from smear layer of debris that fills the orifice of dentin. Tubules forming a smear layer. This one a smear layer, filling and plugging the tubules, the dentinal tubules, making the bonding material hard to be going through these dentinal tubules. This smear layer decreases dentin permeability to 90%. We need the permeability of the dentinal tubule in order for the adhesive or the adhesion material to be inserted in the tubules and make the bonding. Removing this layer increases flow and interferes with adhesion of hydrophobic resin. Removing this layer increases fluid flow and interferes at the same time with the adhesion of the hydrophobic resin. Then the removing of the smear layer is important. To be removed. But removing it will interfere with the adhesion of hydrophobic resin. The next slide, we have the stress at resin-dentin interface. The stress at the resin-dentin interface composites shrink as they polymerize. The composites shrink as they polymerize, creating considerable stress within composite mass, depending on the configuration of the preparation. Again, let's read this again. Composites shrink as they polymerize, creating considerable stress within the composite mass, depending on the configuration of the preparation. When the composite is bonded to one structure, stresses within the composites are relieved by flow form. The unbonded surface. Configuration factor. Let's read this one again. When the composite is bonded to one structure, stresses within the composite are relieved from the unbonded surface configuration factor. And this just means that the class 4 is easier to apply than class 1, or it will be more resistance, and the shrinkage of the material will cause less damage than the class 1, because in class 1 we have 5 surfaces that must be shrinked, connecting to walls. When the one wall and the only wall that is not connected to the tooth, as we can see in this picture, in this drawing. This is class 1. And this is the filling with 1, 2, 3, and 4 walls. Also another wall behind the picture here. And the only occlusal wall, this one here, would be unbonded. In this case 5 to 1. Again 1, 2, 3, 4, and 5 bonded walls. This one 5 bonded walls, and only 1 occlusal unbonded wall, making it easier for the shrinkage to damage the bonding material. When in the class 4 is easier as there is only one wall that is attached here. This is the wall, will be the only wall that is attached to the teeth, and the other three will be free. Here we can see free walls. These are all free walls that will not affect the teeth. Configuration factor, C factor, ratio between number of bonded surfaces and number of unbonded surfaces, as we just explained. Then we have the high C factor, less stress relief. Or the higher the C factor, the less the stress relief. Unrelieved stress, debonding, causing micro gaps, which leads to micro leakage and post-operative sensation. Then a reoccurrence of caries and discoloration, all of which are a direct cause from unrelieved stress. The unrelieved stress being the class 1 and the relieved stress being the class 4. This one is class 4. This is 4. Class 4. This all lead to this coloration and reoccurrence of caries, pain sensation, micro leakage, debonding, then micro gaps, and of course unrelieved stress because of the high number of walls surrounding, or the walls that are attached to the restorative material and attached to the bonding material. 17 MPa bonding strength is necessary to relieve composite strain, composite shrinkage stress. And of course, the bonding material was 20 to 30 millipascal, which is enough in case there is not many unbonded. There is enough, and there is not many attached walls. Also, debonding or microleakage can occur in cyclic loading, which is chewing, changed environmental temperature, hot tea, ice cream, due to linear coefficient of thermal expansion for composites 4 times more than that of tooth. As we can see, 4 times is very high number. And it could cause a very high shrinkage, compared with the enamel. This is the change in environmental temperature, hot tea, ice cream, linear coefficient of thermal expansion for composites, more than of the tooth, enamel or the tooth. And of course, this is being for the enamel or the composite. For times higher than the tooth. There is a note here: resin absorbs water and expands and compensates the shrinkage. But this needs long time. Of course, this is talking about hydrophilic resin, which resists the shrinkage of the composite. Extended bevel provides good peripheral seal, and the bevel increase retention, increases the border seal, and decreases the eye disjunction or distinguishing. The bevel increases the retention, increases border seal, decreases eye distinguishing. The generations of dentin adhesion is a very important subject that we shall discuss right now. And of course, we have 6 generations. The most important are the last 3 generations. Let's talk with the first one. Development of the surface active co-monomer NPG-GMA and phenylglycine glycidyl methacrylate chelates with calcium on tooth surface forming water resistance, chemical bonding of resin to dentin to dentinal calcium. Bonding strength ranged from 2 millipascal to 3 millipascal, which is very low for clinical results and undercuts. This is the first generation, which is not widely used, but it was used in the early days of inventing the resin or the adhesion.
Generations dentin adhesion 1st generation development of the surface active comonomer, NPG-GMA, and phenylglycine glycidyl methacrylate chelates with calcium on the tooth surface forming water-resistant chemical bonds of resin to dentinal calcium. Bonding strength ranged from 2 to 3 MPa. Poor clinical results and undercuts.
Again,
Generations dentin adhesion 1st generation development of the surface active comonomer, NPG-GMA, and phenylglycine glycidyl methacrylate chelates with calcium on the tooth surface forming water-resistant chemical bonds of resin to dentinal calcium. Bonding strength ranged from 2 to 3 MPa. Poor clinical results and undercuts.
poor clinical results and undercuts, the main feature of first generation of dentinal adhesion material, which is an phenylglycine glycidyl methacrylates. The only advantage is that it was water resistance to chemical bonding of resin to dentinal calcium. Next slide is the second generation. Quick summary of the first or the second
2ND generation 1978 development of phosphate ester material, phenyl P and hydroxyethyl methacrylate HEMA in ethanol. Depended on polar interaction between negatively charged phosphate groups in resin and positively charged calcium ions in smear layer. Weakest link between smear layer and tooth loose attachment. Bond strength ranged from 1 to 5 MPa. Poor clinical results plus undercuts.
Again, let's read it.
2ND generation 1978 development of phosphate ester material, phenyl P and hydroxyethyl methacrylate HEMA in ethanol. Depended on polar interaction between negatively charged phosphate groups in resin and positively charged calcium ions in smear layer. Weakest link between smear layer and tooth loose attachment. Bond strength ranged from 1 to 5 MPa. Poor clinical results plus undercuts.
Let's read it slower this time. Tooth, second generation, 1978. Second generation, 1978. Developed of phosphate ester material, phenyl P and dihydroxyethyl methacrylate, HEMA and ethanol, dependent on polar interaction between negatively charged phosphate groups in resin and positively charged calcium ions in smear layer. Weakest link between smear layer and tooth, which could cause loose attachment. Bone strength ranged from 1 to 5 millipascal, with a poor result plus undercuts. Then we move to the third generation, developments of smear layer treatment materials. Developments of smear layer treatment materials. Acidic primers or acidic primers that did not remove smear layer but modify it. Aqueous solution for 2.5% metallic acid, 55% HEMA and methacrylate acid. Aqueous solution of 2.5 metallic acid, 55% HEMA and methacrylic acid. Another concept, removing of smear layer by EDTA. Ethylenidamine tetraacetic acid, chelating agent, then primer 5%. Glutaraldehyde and 35% HEMA in water. Impaired and poor clinical results. Impaired and poor clinical results. There's the third generation development of a smear layer treatment material. Let's read it with the robotic voice. Then we might understand it even better. The third generation.
3rd generation developments of smear layer treatment materials, acidic primers, that did not remove smear layer but modify it. Aqueous solution of 2.5% maleic acid, 55% HEMA and methacrylic acid. Another concept, removing of smear layer by EDTA, ethylenediamine tetraacetic acid chelating agent, then primer, 5% glutaraldehyde and 35% HEMA in water, impaired and poor clinical results.
Next is the fourth generation, 1990 till today, development of acid etching dentin consideration. Remove all smear layer, as we can see, by acid etch, because clinical technique involves the application of acid and both enamel and dentin. So it's named total etch, and now it is named etch and rinse technique, containing 3 steps of adhesive. Again, the fourth generation, 1990 till today, development of acid etching dentin consideration. Remove all smear layer by acid etch, because clinical technique involves application of acid on both enamel and dentin, so it is named total etch. Now it is named etch and rinse technique. It was called before the total etch, now it is called etch and rinse, involving 3-step adhesive. The first one being the acid etching, removing, or the acid etch removes smear layer and demineralizes peritubular and intertubular dentin, exposing orifices and forming filiform collagen network with low surface free energy, and so The first step, acid etch, remove the smear layer, demineralizing peritubular and intertubular dentin exposing orifices and forming a fully formed collagen network with low surface free energy. So the first step being the etching, which removes smear layer and demineralizes peritubular, intertubular, dentinal exposing orifices and forming filiform collagen network with low surface free energy. The second step, we should apply a hydrophilic monomer primer in ethanol, acetone or water to increase surface free energy. We should apply a hydrophilic monomer primer in ethanol, acetone or water to increase surface free energy. Then the third application of adhesive hydrophobic as by IS, GMA, bisophenol, glycidyl methacrylate acid. Let's read this paragraph again in order to understand it fully.
1. Acid etching removes smear layer and demineralizes peritubular and intertubular dentin exposing orifices and forming filiform collagen network with low surface free energy, and so too. We should apply a hydrophilic monomer primer in ethanol, acetone or water to increase surface free energy. Then 3. Apply adhesive hydrophobic as bis GMA bisphenol glycidyl methacrylate acid.
Hydrophobic as GMA bisophenol glyceryl methacrylate acid. All these steps are important, of course, in application of the fourth generation. First is acid etching, removes the smear layer and demineralizes peritubular and intertubular dentin exposing the orifice and forming filiform collagen network with low surface free energy. Second step, again I will read the first step. Acid etching removes smear layer, demineralizes peritubular and intertubular dentin exposing the orifices and forming filiform collagen network with low surface and free energy. Second step, we should apply a hydrophilic monomer primer in ethanol, acetone or water to increase free energy. Third step, applying adhesive hydrophobic as GMA bisphenol glyceryl methacrylate acid. This is the picture that explains the bonding strength, which is between 17 and 30, which is optimal. Next, good clinical results, no undercuts. The only problem is that it includes many steps, 3 steps, which requires more timing and more possibility of making mistakes. This is the first step, etching resin, dentin smear layer. Here you can see the smear layer, dentin smear layer, the prepared with bore, that's prepared with bore. Here we can see it, which is prepared with a bore, the dentin smear layer. Then the next step here, and the third step, So this is the second step after adding etching and rinsing. So first we should prepare the dentin smear layer with the bore. Of course, adding the etching material and rinsing it. We have this picture, the etched dentin with the exposed collagen fiber. And this is the tubule opened to be, or for the adhesive, the primer adhesive is being added with a composite. And the third picture is the composite dentinized and hydrolyzed layer. So the first is preparing with the bore. Second is etching and rinsing. Third is prime, adhesive and composite. Adding is the adhesive and the composite are added to the layer, hybrid layer and tubules. All three steps are here. Let's talk about the fifth generation, also called the two-step etched and rinse adhesive. The two-step rinsed and etched adhesive. This one here, fifth generation, two-step etched and rinse adhesive. From its name, it's only will have two steps. The first is etching, the second is rinsing. It needs one bottle of primer, and bonding is one container. But acid etching is a separate procedure. So etching, then rinsing, it needs a primer and the bonding, and the procedure of etching is a separate procedure. Let's see what is this generation all about. Collapse of etched dentin by air. This is the collapse of etched material by air. In this picture we can see which contain moist etched dentin and dried etched dentin. This is the moist. And there is air between them. Interfibrillar water, collagen fiber. Here the collagen fiber and this interfibrillar water, the residual mineral crystals and the dentin. This one is a dried etched dentin and the collapsed collagen. Let's go to the sixth generation here. The two-step also, this one contains two steps of self-etched adhesive. This is the last generation that we will be using nowadays, the fourth being the first generation that is still being used. Then we have the fifth. Now we are studying the sixth. Two-step of self-etch adhesive. What are these two steps? The first is acid etch primer, self-etched primer, SEF bonding. So the first is acid etch plus primer equals self-etch primer, which equals self-etched primer. Plus bond, of course. These are the two steps, 1 and 2. This generation needs or requires nourishing conditions to control collapse. This is a picture showing the sixth generation. This is notes of the nourishing condition, mild condition, moderate condition. And there is another generation which is called the seventh generation. That includes only one step, self-etching adhesive. Let's just talk about sixth generation picture. The self-etching primer, the dentin smell greater bore here, which needs no rinsing, only a primer. The adhesive plus composite. This is the composite being applied. There's a hybrid lead and resin impressed or impregnated smear plug. Only two steps. Dentin smear layer, no rinsing, and composite prime adding. Notes of nourishment. Condition: do not etch enamel. Enough. Causing less enamel bonding and strength. SEP classification. SEP being the, we have already discussed the, 1 second, let's see. The self-etching primers was the SEP. And these are the notes. please read this page while I do something here. Okay, so I finished. Now let's read this page again. Let me clean this mess here. Just make a razor. And let's do this. Okay, that's better. And let's go again and read it. Maybe you will understand this time. These notes about generation 6, or the generation 6, which are talking about the nourishment. The nourishment condition do not etch enamel. The nourishment condition do not etch enamel. Here we can see that. Enough, causing less enamel bonding strength, SEP classification. Of course, the self-enamel SEP, let me see what is SEP. It is related to smear layer or the self-etched primers, self-etched primers. This is the SEP. So nourishment condition do not etch enamel enough, less enamel bonding strength, SEP classification, self-enamel, self-etching primers, mild condition, excellent dentin bond, plus bore enamel bond. Moderate in between, aggressive conditioner, poor dentin bond, excellent enamel bond. And this is the problem with the 6th generation. You either get a poor dentin bond and excellent enamel bond, or you get an excellent dentin bond and poor enamel bond. But the best way is to do it moderately in between to get a moderate dentin and enamel bond. This is all about nourishment or nourishing conditioner, which could etch enamel enough. Next we have separate enamel etch technique. Enamel etching only has improved enamel bonding strength. Separate enamel etch technique, enamel etching only has improved enamel bond strength. Last point, addition or adding phosphonated resin monomer. This monomer bonds chemically with hydroxyapatite by forming calcium phosphate salts. Again, let's read it again. Adding phosphated or phosphonated resin monomer. will bond chemically with hydroxyapatite by forming calcium phosphate salt. Next slide. The seventh generation one step, self-etched adhesive prime plus bond in one container, all in one. 5-to-5 conservative coats and increased bond strength. Adding extra coat of bond increases bond strength, only 2 steps. This was only 2 steps. 1 step of self-adhesive and 2 steps of adding extra coat of bond increases bonding strength. Acid primer plus bond in one container. 5-to-4 conservative coats increase bond strength, and adding extra coat of bonding increases strength. We finish this lecture now. The 34 slide about this lecture. The enamel and dentin adhesion lecture. We studied in this lecture the generations, enamel and dentin adhesion. Many subjects in this lecture were important in our studying of dentistry, adhesive and adhesion strength. And this slide, 1 out of 35 slides that we have studied in this long lecture. At the beginning we studied the adhesion or the adhesion, which was a state in which 2 surfaces are held together by interfacial forces, which either valence forces or interlocking forces. And we still do not know what is valence force, a structure or the valence and the interlocking forces are within the adhesion, and the adhesive includes the viscous fluid that joins the 2 surfaces, and the adhesion strength is the bond that measure the load of bearing capacity. Advantages of adhesion: less active preparation and more conservative retention. This is the advantage of adhesion. Less cavity preparation it needs and more conservative, of course. It strengthens the unsupported enamel, occluding dentin, the occluding dentinal tubules, decreased phosphorylation. Then we study the adhesion, bonding, and the adhesion is the same as bonding, we said. There are 4 types in operative dentistry: the mechanical, the absorption being the chemical bonding, inorganic, hydroxyapatite, organic, collagen, mainly type 1. Mechanical, within the tags of the tooth structure. The diffusion, precipitation of substances, surface on resin monomer. Combination all of the above, the adsorption, the diffusion, and the next slide we can see the good adhesion achieved by close contact between bond, resin and enamel dentin. The surface tension of bond must be less than surface free energy. In this slide we can see the good adhesion that is achieved by close contact, bond, resin and enamel dentin. Surface tension of bond must be lesser than the surface tension of bond here must be lesser than surface free energy. Adhesion failure, cohesive failure, the adhesive failure. Adhesive failure is between joints, and the cohesive failure is between the substrate or the adhesive material. This is the cohesive failure and the adhesive failure. As we said before, the adhesion and the adhesive and the cohesive failure, the cohesive failure and the adhesive failure. Cohesive is the same as the adhesive. Also, the friable enamel is considered a cohesive failure, or an infected enamel with corrosion or caries. Next, number 3 was the adhesive joints failure. Polymerization shrinkage occurred due to all methacrylate-based resin shrinkage. Major problem, so the adhesive must provide strong bond to resist stress of resin shrinkage. The strong bond. Next slide, the enamel adhesion. The Buonocore, which is 85% phosphoric acid, is an enamel adhesion used as an etching agent. Acid etching transfers smooth enamel surface to a regular surface. This is the phosphoric acid, which is the same as Buonocore substrate or material. Transferring the enamel to a regular increase surface free energy, increase its surface free energy, its bicapillary action, etc. This is the etching with dissolution of type 1 microorganism, then the type 2 dissolution of periphery, type 3 dissolution of both, replica of enamel, all because of the acid etching. 37% phosphoric acid, which is the same as we studied before, the butyric phosphoric acid. For 1 minute, 85% phosphoric acid, Buonocore phosphoric acid, 37%, with a 30 to 40 concentration. The time being used is 15 to 30 seconds of etching with phosphoric acid. Here we have 1 minute of phosphoric Buonocore, but here exactly with this type of phosphoric acid, 37%, which is widely used in dentistry and etching, is only 30 to 50 seconds, not a minute. If they increased than normal, prescription of calcium phosphate groups acts as barriers. Provide a 50 to 20 millipascal liquid and gel. This is the dentin adhesion, micromechanical penetration monomer, chemical for adhesives. And we said that the chemical with GIC polycarboxylate group, phosphate-based monomer with hydroxyapatite. This is the type of adsorption, the chemical bonding adsorption here, inorganic hydroxyapatite, which is one of which is the glass ionomer cement, GIC, polycarboxylic group. Next slide, challenge in dentin bonding, high water 25% and organic contents 25%. This is all a review of this lecture, of course. And this is a challenge in dentin bonding. network of tubules. Dentin-enamel junction is easier to apply than pulp, being only 20,000 tubules per millimeter square with a smaller 0.6 micron diameter. Dentin dynamic substrate depth affected by dentin thickness, more deep cavity, less retention. And the smear layer here, after preparation of toothbrush, residual organic denture, etc., hydroxyapatite, could cause friction and heat, form a smear layer. Debris can fill the tubules, which form a smear plug. This smear layer decreases dentin permeability to 90%. Removing this with an etching material increases the fluid flow and interference of adhesion hydrophobic resin. The stress at resin-dentin interface make a compositor shrinkage, consideration, and configuration factor. There's also things about polymerization and relief. Configuration factor could be here, less walls is better, less walls that contact the bonding material is better, and class 4 is better than class 5 in this case. High C factor, less stress relief. The unrelieved stress here with debonding, micro leakage, 20 to 30 MPa discoloration. As we can see, micro gaps, all because unrelieved stress. Because debonding caused micro gaps, micro leakage was relative sensation and recurrent caries. All cause of unrelieved stress. 14 MPa is the polymerization shrinkage of the composite. The debonding, micro leakage occur, and cycle loading chewing. Changed environmental temperature, like hot tea, will shrink the composite even more. Generations of dentin adhesion. First generation, and phenylglycine, glycyl methacrylate chelates, and poor clinical results plus undercuts. This is only the first generation which is not being used these days. The second generation is not being used too. And this is the third generation. Fourth generation is still used today. As also it requires many steps. The acid etching dentin, remove the smear because of clinical technique. The first or the fourth generation, remove all smear layer by acid technique. It needs 3 steps of adhesive. First, acid etching removes smear layer, demineralizes peritubular and intertubular dentin. Second, we should apply hydrophilic monomer. And the third, applying adhesive. These are the pictures showing the dentin smear layer with etched dentin and the resin being added. With a bonding strength of 30 MPa to 17. Good clinical results, no undercuts, many steps, more time, more faults. And these steps are the dentin smear layer preparation. Second step is etched dentin and exposed collagen fibers. Third step is dentin adhesive application and composite. The adhesive, primer, composite, and the acid etch rinsing. Fifth generation is only 2 steps. That means it's better. First is etch, second is rinse, Third is prime and bonding, which is only part of the second step. This is a picture showing the fifth generation with the moist etched dentin and dried etched dentin. Sixth generation, only 2 steps to only the fourth generation being the 3-step adhesive. This generation include the self-etched primers, the primer that is etched on the non-rising condition to control collapse. The self-etched primer here and the adhesive plus composite addition. In the first picture we see the dentin smear layer created by Bohr. Second picture we see no rinsing primer. And the third picture we can see the hybrid layer composite dentin adhesive being applied. So first picture is only the Bohr, second is only the primer, and the third is the dentin adhesive, then the composite. This also includes resin impregnated smear plug. These are some notes about the sixth generation. This is the sixth generation. Sixth generation needs nourishment. Do not etch enamel enough. For not etching enamel enough will cause less enamel bonding strength. SFE self-etched primers. Classification: mild conditioner, excellent dentin bonding plus poor enamel bonding. This nourishment includes the application of conditioner. All 3 variation of application of conditioner with more conditioner having an excellent dentin bonding and less conditioner, more conditioner being good enamel bonding. The aggressive conditioner having an excellent enamel bonding, and the mild conditioner having a low enamel bonding. So the conditioner increases the enamel bonding, but the conditioner at the same time decreases the dentin bonding. Separate enamel etch technique: enamel etching, addition of phenophosphate resin. This monomer bonds chemically with hydroxyapatite by forming calcium phosphate salts. And the last generation is the 7th generation. This generation having 1-step self-etched adhesive, only 1 step in the process of self-etched adhesive procedure. Why it is 1 step? Well, because acid primer bonding are all in the same container, all in one. Acid, and the acid which causes the etching, which contains the etching material, which is the phosphate acid, and the primer, which is the adhesive material, and the bonding is also adhesive material. Then all of these 3 are in one container. 4 to 3 consecutive coats increase bond strength. Addition of extra coat of bond increase bonding strength. This will contain 2 steps instead of 1 step. And here we have only 1 step of this generation, 7th generation, without addition of the 2nd step. And of course, the acid being the acid is the acid that is used in etching or as an etching material is the bond, which is also called adhesive. And cohesive. The acid used for etching is phosphoric acid. Phosphoric acid. This one is the phosphoric acid. As we can hear it here, the phosphoric acid.
Phosphoric. Phosphoric.
Thanks for joining this. Thanks for joining us in this lecture, and we will finish this lecture right away. We learned many informations about the materials and the bonding, enamel and dentin bonding.